All right, so make sure you guys are seeing it. So this is kind of the last kind of example I'll do for Excel. Just some additional stuff you can do pretty quickly. We've talked about a little bit of it already, just in terms of the theory in the earlier videos. But I'm going to pick up on one of the things that we had left off on. And looks like here, as I'm doing this, I realized I forgot my end on regression. So here's my we had that data, well, I get this out of the way, where we're looking at college GPAs and a bunch of different student characteristics. And we were talking about, we had this limited variable problem where if we just want to look at the effect of being a student athlete, controlling risk for SAT, greatly change the coefficient and the statistical significance. But we also kind of then threw in this like catch-all, kitchen sink or catch-all one where we include every single variable that we had, in our data set. So we're trying to predict GPAs using all of this different information on the students. So what I could do very quickly is I want to say, okay, look, I know that each one of these variables has their own coefficient, right? Has their own impact on my Y variable, which was college GPA. But are they statistically significant? Can I say that there actually is an effect? Because remember, we start out assuming that that slope coefficient is always equal to 0. So what we're going to do is say, okay, look, we are only going to reject that null, which that there's no effect, or if I'm rejecting that there's no effect, I'm saying there is an effect, if that p-value is less than our desired alpha. So let's say I'm going to be making rejection decisions, and I don't know, I'll do the 99% level, right? So I'm going to reject at the 99% level. My alpha is 0.01. So what I'm going to do is I'm going to use this built-in if statement to test to see whether or not the p-value is less than 0.01. If it is, I should be putting in the word reject, comma, if it's not, well, then I should be failing to reject the null. So here, because I've used my cell reference, what I could then do, double left click, quickly do this for every single one of my coefficients, or every single one of my, variables coefficients. So we can see here, I can reject the null for almost every variable here. So I can say that the intercept, but SAT scores, being an athlete, high school rank, female, whether or not the individual was classified as Black, total credit hours, high school size, they all appear to have a significant effect on my college GPA. The only ones that don't would be what this verbal math score. So if I'm the admissions department, maybe I'm like, well, why are we spending all this money and time on this test? It's not good at making any better predictions about someone's GPA. We shouldn't be taking, focusing too much on it. And then kind of our racial or demographic control of whether or not the student was white also seems to not have an effect. So we can come very quickly with our rejection decisions. Another thing that I want to point out you can do is very quickly make a prediction. So let's say I have this hypothetical person, and I don't know. Let's say I want to know what's the predicted predicted GPA for someone who has an SAT score of 1200. They are a student athlete, so that variable will be a 1. Their verbal math score, and this is where I should have taken a glance at this. I forget what that range is. Yeah, it looks like somewhere, those values. Let's say they had like a 1.2. I think that's a reasonable one if you look at the data. Their high school ranking, maybe they're 34th in their class. They're male, so we'll put a 0 for the female variable. They're neither classified as either white or as Black, right? There's some other racial demographic. Total credit hours that they've taken in that current semester, let's say it's 15. Whoops. And then their high school size, once again, I have to remind myself, it's kind of a weird variable. It's scaled, so 2.66. So I think these represent thousands. So let's say they had a school of 2,000 or 2.00. In fact, we could even, let's say 2,222. There you go. All right. So here I've got my hypothetical person. I've got all the different X values for these different variables. Now, when I'm thinking about my linear regression equation, it's simply taking the coefficient for that variable, multiplying it by whatever the value was for that individual. Right? So I'm going to go through and do is find for each variable the value for this person, hypothetical person, and multiply that by the coefficient. So I'll take the coefficient on SAT, multiply that by this person's hypothetical SAT score. I'm then going to want to do that for every single variable and then add them all up. Now notice when I have variables that take on a value, x value of 0, they don't, they don't make any difference in my predicted y variable of GPA. Now, the one thing I've forgotten here, if I simply add all of these up, right, I will get my predicted GPA. So, however, I forgot to add in one thing, which was I didn't add in the intercept. So I can do this one of two ways, right? So I could say, okay, take the sum of all these coefficients times the hypothetical x values, and then add to that my coefficient on the intercept. Add to that my coefficient on the intercept, right? I could do it that way. What I could also do is say, well, look, I know that the intercept always gets added in, so I'm just going to put like a value of 1 there. That way, when I take the coefficient on the intercept, I multiply by 1, it's just adding that value in. So here, take this value of 1, multiply by that coefficient on the intercept. Now, I'll add up everything, right? It includes now the intercept. Oh, there we go. Oh, what did I do wrong there? I accidentally hit the negative sign. That'll do it. Right? And sure enough, I get the same value. So that's a quick way we can kind of make predictions. Even when we don't have to do this by hand. We've got, sometimes you can have regressions with, tens, dozens, even 100 variables. This is a way you could do it very quickly, come up with that prediction. Okay. Another thing I wanted to point out, and I don't ask you to do this in the Excel assignment, but just to kind of be complete and kind of showing you what I'm doing here. So we had this S statistic, and we could kind of go through how we would kind of find that p-value. Remember, this is the overall significance of our model. This p-value is basically 0. So you could do a very similar thing, right, as we did with our if statement here, to kind of create an additional cell where we said, okay, if this is less than, our hypothetical alpha of 0.01, can we reject that the model has, no predictive power at all? Here with the p-value is basically 0. We clearly can reject that and say that this model does have some statistical significant power in predicting college GPAs. Okay. All right, so that's kind of just a quick little video there. Should kind of cover everything we need. Just to kind of go over some additional things. We've got our R squared. We're explaining about 29% of the variation in GPAs using all of our variables here. If I was going to rerun this model, maybe I don't need to include these variables that I failed to reject the null on because I can't say they have a statistically significant effect. But other than that, this should kind of round out everything you should need to know for linear regression and the types of questions that I could ask you.